Good morning, guys. Here's the video for the Chapter 4 study guide. I'm going to work through a few of these problems. I will not work through them all. Again, I want you to kind of get some practice with them, but I will work some of them since we're out of class today and tomorrow. Just want to give you a video of some kind of instructions, and hopefully this instruction can help you out. But I will take questions on Monday if there's any confusion, you couldn't figure something out. So let's start with this first one. Identify the holes, vertical asymptotes, horizontal asymptote in the domain of each, then sketch the graph. So I always start with horizontal asymptotes in this. And if you go back and look at your notes, horizontal asymptotes is determined by the degrees of the polynomials in the numerator and the denominator. So the degree of the numerator here is 3. The degree is the highest power of a polynomial. The degree of the denominator is 2. So we would say the degree is greater in the numerator than the denominator. So we call that top-heavy. And when you have a top-heavy rational fraction here, or rational function, excuse me, you would have, there is no horizontal asymptote. There's none. All right. Now, if you look over here, the horizontal asymptote, if you look over here, the horizontal asymptote, notice that the degree in the denominator is bigger than the degree in the numerator, so we would call that bottom heavy, and when it's bottom heavy, the horizontal asymptote is y equals 0. And then the third kind of horizontal asymptote you can have would be if you had something that looked like this, 2x squared over plus x plus 2 over 3x squared plus x minus 3. So if you had something like this, notice that the powers are the same. So the horizontal asymptote here would simply be y equals, y equals 2/3. Because when the powers are the same, it's a ratio of the coefficients. Now, slipping back down here, so that takes care of our horizontal asymptote. Now let's move to our vertical asymptote. Now the vertical asymptote, you find the vertical asymptote of a rational function by setting the denominator equal to 0. So negative 4x squared minus 4x, and we set that equal to 0. Now this is a quadratic equation, guys. You're never going to isolate one of these x's because there's no way to get them together. So you have to factor. What can I factor out of each one of these? I can factor out a negative 4x. When I do that, I am left with x, and if I factor a negative 4x out of negative 4x x squared, I would be left with an x. Always think you can distribute that and check that. Make sure the factor is correct. And then what's negative 4x divided by negative 4x? And that would be that positive 1. So we have the zero product property here tells us that if a times b is equal to 0, then a equals 0 and b equals 0. So from here we divide both sides by negative 4 and we get x is equal to 0. And here we subtract 1 from both sides and we get x is equal to negative 1. So both of these make the denominator 0. Now, a number that makes the denominator 0 is a vertical asymptote. But a number that makes the denominator and the numerator 0, I'm going to say it again. A number that makes the denominator and the numerator 0 is what we call a whole. So we have two options here to determine if either one of these are the only two numbers that will make the denominator 0. So we want to determine, will one of these make the numerator 0? You have two options to see that. The first option would be to factor the numerator. Factor it and see if it has any factors of 0 and negative 1. Or your second option, maybe this is a little bit easier, is to plug both numbers back into just the numerators to see what number you get. So it should be pretty obvious that if you plug in 0 into the numerator, 2x squared minus 3x, if you plug in 0 here, guys, it should be pretty obvious to you that you are going to get 0 in the end. 0 cubed is 0, plus 2 times 0 squared is 0, minus 3 times 0 is 0. So it should be pretty obvious that 0 not only makes the denominator 0, but it makes the numerator 0 as well. And that means that that is a whole. Now, I wouldn't assume that negative 1 is a, I would not assume that negative 1 is a whole as well, but let's plug it in. So that would be negative 1 cubed plus 2 times negative 1 squared minus 3 times negative 1. And the question is, what does that equal to? So negative 1 cubed would actually still be negative 1 because a negative number to an odd power is negative. This right here, negative 1 squared is 1, so that's just negative 1 plus 2 and then plus 3. So negative 1 plus 2 is 1. 1 plus 3 is 4. Now, that actually that just kind of confirms that negative 1 just makes the denominator 0, but not the numerator, meaning that this is a vertical asymptote. But because we checked that by plugging negative 1 in, we actually now kind of have we have some xy coordinates. When, actually, I can't really say that just because we only did the numerator, so it can kind of get you started with an xy coordinate, and that's what we're going to need in order to graph this. Okay, so and we'll get kind of to that. Well, I guess we probably need to lead to that right now. So there is a vertical asymptote at negative 1. So let's put that on the graph. So there's a vertical asymptote right here at negative 1. And we know that there's a hole at 0. Okay. Now the hole at 0, we don't know really where it is on the y-axis. We know that there's no horizontal asymptote, so we know these graphs are going to continue on whatever it may be. But this 0 could be anywhere, and really we just needed to pick some other points here in order to determine some other things. So we know that negative 1 is the vertical asymptote, so we wouldn't want to use that. But we want to find some xy points here in order to determine where this graph is doing. Now, I think I let you use your calculator on the homework, but again, you're not going to have the calculator here, so you just need to plug values in to see. I would actually start, you know that negative 1, you can't use negative 1. Now, I said negative 1 kind of gives you the numerator, but negative 1 is a vertical asymptote. So you don't want to plug in negative 1. We already know what that's going to produce. You don't want to plug in 0 because we know what that's going to produce. So pick like 1. When x is 1, what is the y? So guys, literally what we'd have to do here is just plug in 1 to everything. So 1 cubed plus 2 times 1 squared minus 3 times 1 all over negative 4 times 1 squared minus 4 times 1. This may be time consuming, but this is kind of the part of it. So 1 plus 2 minus 3 all over negative 4 minus 4. That's going to be equal to 1 cubed is 1, 2 is 2. Okay. So this is going to be, 3 minus 3 is 0 and over negative 8. Now, that just took me for a loop for a second. I just had to make sure. So when x is 1, the y is 0. So when x is 1, the y is 0. So we have a point right there. All right. Now what you would want to do here is go ahead and plug in 2 as well. Now I'm going to use some space here, and this is just kind of part of it. So 2 cubed plus 2 times 2 squared minus 3 times 2. Now some of you picked up on a pattern, but I'm not going to teach that pattern. I would just tell you to plug it in. So 2 squared minus 4 times 2. So again, we're trying to make the xy table for this graph in order to graph it. You're not going to be able to use your calculator, so you got to do this work. So 2 cubed is 8 plus 2 times 4 is 8 minus 6 all over negative 4 times 4 minus 8. So that's going to be 16 minus 6 is 10. And negative 4 times 4 is negative 16. Negative 16 minus 8 is negative 24. Now, as you see this, guys, this is like, oh, well, how in the world do we solve that? Well, here's the thing. It's when x is 2, you could simplify this down. 2 goes into both of them to 5 over 12. So, and it's going to be negative. So, negative 5/12. So, 2 and negative 5/12 is doing that right there, guys. All right? So, as you should see here, this is, again, we're just looking for a sketch. This is going to be coming down here. Now, there's going to be a hole at 0. Again, I'm not looking for exact, but it should be looking something like this. And that really doesn't, I kind of have it leveling off there. I'm not going to go crazy on you here. Just kind of looking for the sketch. Okay. And now, if you wanted to plug in a negative 2, you could here. If you want to plug in a negative 2, you could. But you should know that these always go the opposite direction. So this actually should be coming around here like this. Going down. It's always going opposite of what that one is. And that shouldn't be any different for the test. So I know that's a big problem there. I know it's a lot of work getting the x and y and like finding out the graph. And I'm sure it comes in probably a little bit closer to that, because if we plug, again, we could figure this out by plugging in negative 2. Again, starting with 1, that's a pretty tough problem. So, all right, let's go to number 3. So that's how, or actually, it did ask for the domain. Boy, this is a massive problem. What is the math teacher thinking? So what's the domain here? The domain is going to be from negative infinity all the way to negative 1. Union, then it's going to go from negative 1 to 0, and then union 0 to infinity. Because we have to include that hole in there. Okay? So from here, this is all good. It's not good there. From negative 1 to 0, it's good. But at 0, it's no good. From 0 to infinity, it's good. That would be our domain. You're going to have to write that out verbatim. So, skipping through here, simplify each and state the excluded values. So, the top, when we're simplifying these things, we always need to factor. So, if you're looking at this top, n squared minus 16n plus 60, so what multiplies to be 60 but adds to be negative 16? That should be pretty obvious to you. N minus 6 and n minus 10. Negative 10 times negative 6 is positive 60, and negative 6 minus 10 is negative 16. And we put that all over. Now, this was a question that somebody was asking yesterday. So you actually do have to factor that negative out. So factor that negative out, and you would actually have n squared minus 20n minus 100. And then now factor that. That's n minus 6 in the top still over n minus 10 all over. Now, if you factor this right here, what multiplies to be negative 100 adds to be negative 20. That should be n minus 10, n minus 10. These factors are the same, so we can cancel them, and then we could really distribute that negative back in here, and we have n minus 6 over negative n plus 10. The excluded value is going to come from here, so it's really just setting this equal to 0, setting that denominator there equal to 0. Negative n plus 10 is equal to 0. So when you're looking at that let me restate that, what I just said, guys. It's actually coming from this right here. It's coming from both of those. So it just so happens to be that 10 is the number that cancels both of these. but you really got to go back to the factored of the denominator. Any number that makes this 0, which could be either one of these factors, and here it's the same factor, either one of those that makes it 0 is an excluded value. So here if you subtract 10 from both sides, you get n is equal to 10. So 10 would be the excluded value. Okay, and that would be my answer there. Okay, now looking at 4, I want to work 4 just to kind of clarify this point. So if I factor the numerator, what multiplies to be negative 27 but adds to be negative 6? That would be k minus 9, k plus 3. Okay? And then kind of the same thing right here, guys. Notice that this is written a little backwards here. We know that we could rewrite that as negative k squared plus 8k plus 9. And then you want to factor that negative out. Negative k squared minus 8k minus 9. The reason that you can't factor with a leading coefficient of negative is because the factoring by grouping won't work then. You'll get an answer, but it simply won't work there. So now looking okay, sorry. Had a little brain lapse there for a minute. So what will multiply? I'm sorry, I was just thinking like 3 and 3 don't add to be 8, but I'm sorry, I forgot negative 9, negative 1. So what multiplies to be negative 9 but adds to be negative 8? And that's our factors there. So keep that negative out there. And it's going to be k minus 9, k minus 9, and k plus 1. Negative 9 times 1 multiplies to be negative 9, and negative 9 plus 1 is negative 8. So in this case, we should see that this cancels, and this cancels, and we're left with k plus 3 over negative k minus 1. Now, some of you had brought this up to me, and you said, hey, my the answer key has negative k minus 3 and k plus 1. And that's fine because what it is they just put this negative up in the numerator. Remember, this negative can always, since it's a fraction here, we can put it in the side. We can put it to the side, or we could put it in the numerator or the denominator. It just can't be in both. Okay? So the answer key has negative k minus 3 over k plus 1. That's the same thing as this right here. Okay? Now your excluded values, this was the point that I wanted to talk about. Like over here it was the same. You need to set the factored denominator equal to 0 in order for you to determine what it is, what the excluded values are. So negative k minus 9, k plus 1 is equal to 0. So in this case right here, you don't have to worry about this negative out here. You can just set both of these equal to 0 because that's like a negative 1. Negative 1 equals 0 doesn't make any sense because that's a times b times c equals 0. So that doesn't make any sense, so you can just kind of get rid of it. Mathematically, if you're like, hey, well, that doesn't make sense to me, how can I do that? Well, just divide everything by negative 1, and that takes care of the negative, but that's still 0 over here. So then you just set k minus 9 equal to 0 and k plus 1 equal to 0. And there we get 9 and negative 1. And those are excluded values. So over here, it just happened to be that 10 was the one for both, but you got to set that denominator, both of them equal to 0 in order to determine the excluded values. So this right here is what we came up with, and our excluded would be this. And that's simplifying rational functions. Now let's continue on. Sorry, I don't mean to take time, but those are kind of two pressing problems, and obviously number 1's a pretty massive problem. That's why I only put 2 of these on the test, because I understand they were so large in detail. So going to 5, when you're multiplying rational functions, here's what I always say: always factor everything. Factor everything you can. So x squared minus 16, that's actually, we could rewrite that as x squared minus 4 squared, which is a difference of squares. So that's actually x minus 4, x plus 4. And we put that over x minus 1, and then times x minus 1. Those can't be factored. And then 5 can't be factored. So from here, it should be pretty obvious that x minus 1 and x minus 1 cancels. And then I can't really cancel anything here, so my answer is going to be x minus 4, x plus 4, or you could keep it in x squared minus 16 over 5. Now your excluded values with multiplication, you always set both denominators equal to 0, guys. So over here, you're going to have to set both of those equal to 0 in order to determine the excluded values. So with number 6, you're going to have 2 excluded values, because both of these are going to give you a different value that would make them 0, which makes this impossible. Over here, if you set that equal to 0, that doesn't make any sense, so you don't have to worry about that. That's just a constant. But if you set this equal to 0, x minus 1 equals 0, x is equal to 1. So our excluded value here is going to be 1. Because if you plug in 1 here at any time, it obviously kind of destroys the whole problem. Okay, that is that. Now going on to 7. 1 over m plus 4 divided by m minus 5 over 4m cubed minus 20m. So this, you're going to have to say 1 over m plus 4, but then you've got to switch this sign, times 4m cubed minus 20m squared all over m minus 5. So we keep the first one, we change the sign, we do the reciprocal. Now, within this, you want to factor everything. So 1 can't be factored, m plus 4 can't be factored, and then I just need to factor this right here. So I can pull out a 4m squared. So 4m squared. I can pull a 4 out of the 4 and 20. I can pull m squared out of that. When I do that, I'm left with m minus 5. I'm left with m minus 5, and of course that I put that over m minus 5. Should be pretty obvious to you that this is going to cancel with this. I can't cancel that 4 and that 4 because that's attached with addition. I can't cancel the m and that m because that m is attached with addition. So this is just going to be 4m squared over m plus 4. Now the detail is going to come here. You actually need to set all 3 of these right here equal to 0, or just ask yourself what makes these 0. You don't necessarily have to set them equal to 0, but you just need to say what makes all of these 0. Well, for this one, it should be obvious that it's negative 4. So excluded values, because if that's negative 4, then that's 0, and 0 in the denominator never works. So I know negative 4 is it. Now the math behind that is just, of course, m plus 4 is equal to 0, so m is equal to negative 4. Same thing there. 5 makes that 0. And remember, even though that's in the numerator, because we flip it eventually, if it's 0 at any time, even after the flip, it's not going to do well. And then the last thing would be setting this equal to 0 and then factoring it. Well, we already have it factored right here, and just to show you, so m minus 5 is equal to 0, so obviously you add 5 to both sides, and that's m equals 5. But this one right here, when we set it equal to 0, 4m squared times m minus 5 is equal to 0. That 0 product property, you'd set this equal to 0 and this equal to 0. So we have this, but you divide by 4, you get m squared is equal to 0. You do the square root of both sides. M is equal to, there's no such thing as plus or minus 0, so 0 would make that bad. And then so there's actually 3 excluded values here. So this is our answer. And that's our excluded values. Negative 4 makes that 0, 5 makes that 0, and 5 also makes this 0, but we don't have to repeat it here because we already have it. But that would be m equals 5 as well. And then if you plug 0 into here, think about it. If it has variables and you plug 0 in there, it's going to be 0 with the multiplication. That's that. Let's continue right along. So looking at 9, b plus 3 over 4b cubed plus 12b squared plus 3 over 4b cubed plus 12b squared. So the thing with fractions, if your denominators are the same, you can just simply add the numerators. So the numerators here would be b plus 3 all over 4b cubed plus 12b squared, which comes out to be b plus 6 over 4b cubed plus 12b squared. All right, and that's what we would do there with this. Not looking for excluded values, you're just simplifying those expressions there. All right. So 10. So notice with 10 they have different denominators, and I'm actually going to do this one down here. This one's going to be worked just like this one, but this is subtraction, so I want to show you this one. And there, guys, always be careful. Remember, when you put those together, make sure you say the quantity of that. So n minus 1 minus the quantity of n minus 1. Because you may be thinking there on actually 11, this one's actually pretty straightforward. And just so we clarify this, let me work 11 after looking at it. So this would be n minus 1 minus the quantity of n minus 1 all over 8n minus 8. They're like denominators, so that works. But here, when you distribute that negative, you get n minus 1 minus n plus 1. Well, n minus n cancels, and negative 1 plus 1 is 0. So we have 0 over 8n minus 8. 0 over anything will be 0. So throwing some, this study guide's throwing some good stuff at you all, checking to see, do you know the little things? Do you know the little things in algebra? And that's good. That's good for you all to get that experience with. Now going back to 10 and 12, you'd work them the same way. And here's what you got to do if you can remember. You multiply when you're trying to subtract or add fractions with unlike denominators. Multiply the left fraction by the denominator in the right. And then multiply the right equation by the denominator in the left. Looking like this. So then we get 8, and I always say write this, be careful with that negative sign, minus, and then really it's, if we were to distribute this right now, distribute, we get 24k minus 16. And we put that all over, and then we can distribute this if you want, or you can set it right next to each other, but this would be 12k minus 8. Now, here you distribute, and you would get 8 minus 24k plus 16. You put that all over 12k minus 8. Now 8 plus 16 would be 24. So negative 24k plus 24 all over negative 12k minus 8. Now, you could ask yourself, if I factor this, I'm going to get, if I factor a negative 24 out, I'm going to get k minus 1. But if you factor like a negative 4 here, you're not going to get k minus 1. So there's no reason to factor. But here's what should jump out to you guys, is that all 4 of these can be simplified. So really, I could divide all of these by 4. And that simplifies this to negative 6k plus 6 over negative 3k minus negative 3k. Oh, I'm sorry, that's not a negative 12 there. Sorry. That's at positive 12. So actually just positive 3k. I don't know where I got that negative at. Positive 3k, and then 4 goes into that negative 2 times, or negative 2. And that would be our answer there. All right. So looking at number 13, just kind of working through here, guys. Looking at number 13, solve each equation. Guys, when it's with me and you're asking me like, hey, what should I do? Should I combine these two? Well, you don't have a calculator. Most of you don't know what negative 1/3 plus 7/2 is. So this is where I say always eliminate the fractions by multiplying by the LCM of the denominators. So what's the LCM of 2, 3, and 9? I always say go for the biggest one, but 2 won't go into 9, so then go to the next biggest one of 9, or go to the next multiple of 9. Well, that'd be 18. Does 2 go into 18? Yes. Does 3 go into 18? Yes. Does 9 go into 18? Yes. So the least common multiple here is 18. So if I have 18 here, and I distribute it in, this was on the ACT. I saw a problem just not quite like this. It looked more like this right here. So you got, and it's the same principle. So same thing here. So we would then write this out as this: 18 over 1 times negative 1/3 x plus 18 over 1 times 7 over 2x equals 18 over 1 times negative 76 over 9. From there, we begin to cross simplify. 3 goes into itself once. It'll go into that 6 times, so I have negative 6x, because don't forget that negative sign. 2 goes into itself once. It'll go into 18 9 times. 9 times 7 would be 63. So plus 63x. And that's equal to, 9 goes into itself once. It'll go into 18 twice. 70 is 140, so 152. So, and that's going to be negative 152. Negative 6 plus 63 is the same thing as 63 minus 6. So that's going to take us to 57. So 57x, it's going to be positive, is equal to negative 152. So this is a tough problem. And then divide both sides by 57. And again, this is where just going to have to kind of think it through. And again, this is where you kind of want that. I'm sure a bunch of you would be crying for the calculator here. But you just got to find something that will go into both of those. Okay, finding something that goes into both of those numbers. And just thinking. This is where those divisibility rules come in. And 57, 5 plus 7 is 12. 12 is divisible by 3. So that means 53 will go into 57. 5 plus 7 is 7, plus 1 is 8. 3 won't go into 8, so 3 won't go into both. 2 won't go into both. 4 won't go into both because 57 can't even be cut in half once. 5 can't. 6 because 2 can't go into 57. 6 won't go. We know that 7 doesn't go into 57. 8 doesn't. So then, like, once I'm getting up in that numbers, then I start asking myself, what's 57 divided by 2? It's a decimal. What's 57 divided by 3? And that would be 19. So 19 will go into 57. Will 19 go into 152? 19. Obviously 10 would be 190. Yeah, that's it. It's not 9. 19 times 9. That's too much. 19 times 8. Check 19 times 8. That's 72. That's one. Yeah, there it is. So 19, and I know that seems like a lot, but 19. I'll try to make the test where it's not so, insane like that, but we'll see. Negative 8/3. So negative 8/3 there would be our answer. And that's just guess and check. Got to figure it out. Got to see the math. That mental math is so crucial for us. All right, then skipping around, I'm going to go over here to 16. It gives me a little bit more space. So again, guys, so we're not dealing with a number. Now here you need to multiply everything by 4 in order to, in order to eliminate the variables, or excuse me, the denominators. Looking at 16, 1 over r equals 3 over 2r minus 1 over 2r. Here's what we got to ask ourselves. What, when we multiply this whole thing by, will allow us to eliminate all denominators? I always start with the biggest one and then add to there. So 2r squared, in order to cancel 2r squared, I'm going to have to do 2r squared out here. But will that take care of 2r? Well, yeah, because there's 2r there already. And will that take care of r? Yeah, because we already have 2r. We already have r squared here, or r times r. So 2r squared. Often go look at the biggest one and then ask yourself, can the other ones go into that? And here it would. So we distribute, and then I'm left with this. 2r squared over 1 times 1 over r equals 2r squared over 1 times 3 over 2r. And then right here I would just simply have minus 1 because that and that is the same. So you just bring down the numerator. We cancel some stuff here. R cancels with that R, leaving us just 2R. This 2 cancels with the 2, and that's equal to. This R cancels with one of those, and R times 3 is 3R minus 1. I'm going to rewrite this right here. 2R equals 3R minus 1. I'm going to subtract 2r from both sides and get 0 is equal to r minus 1. And then that should shake out to be, add 1 to both sides, r equals 1. Okay? Jumping down here to these, again, just all 4 of these are going to be the same, and just always remember it says check for extraneous solutions. Okay, check for extraneous solutions, and that should be fun with a problem like 18. So 18 looks the roughest. Let me work that out for us. So 18 looks the roughest. So I'm going to work this out on a separate sheet of paper just because I don't have room here. Sorry, I was trying to save paper and all this. So 1 over x plus 3 plus x squared plus 11x plus 30 all over x squared minus 3x minus 18 is equal to x squared plus 4x plus 4 all over x squared minus 3x minus 18. So, looking at this right here, we want to figure out what this x is, all of this x. So what we're going to have to do is we're going to have to see what the least common denominator here is in order to get rid of all these fractions. So let's factor x squared minus 3x minus 18, see what we get there. So that would be x. What multiplies to be 18 but adds to be negative 3? That would be negative 6 and positive 3. So that would be x minus 6 and x plus 3. Now, that's a good thing, because here's what we're saying, is that we need this right here. Okay? This right here, that's what we're looking at here. This, if we multiply everything times this, which is x squared minus 3x, this is the same thing, guys. If we multiply everything by this, we're going to be able to cancel this. So I'm going to multiply everything by x squared minus 3x minus 18. Now, you may want to look at that as x minus 6, x plus 3. It's the same value. So we're going to distribute, distribute, distribute. Now, over here, it would look like this. X plus 6 times x plus 3 over 1 times 1 over x plus 3. That's where that's coming from right there. Plus, and then guys, we're just going to be able to bring everything down because this is the same as those. X squared plus 11x plus 30 equals x squared plus 4x plus 4. Now over here, this cancels with this, and I'm just left with x plus 6 plus x squared plus 11x plus 30 equals x squared plus 4x plus 4. Now you just need to start combining everything, figuring out. So we got 36 in that. We have 12x, and we have x squared. 11x and x is 12x, and all this is positive, is equal to x squared plus 4x minus 4. So I'm just going to subtract all this out. Minus 4x, add the 4. Oh, nope, that's a positive, right? Yeah. So, and then this would be minus 4 as well. That cancels on that side. And then this cancels, and then I'm left with, that would be 8x. That would be 8x plus 32 equals 0. And I just looked, I'm getting something else. I'm looking at the answer key, and the answer key, I just looked at the answer key just to double check, because this is a big problem, and the answer key is saying negative 5/2. So I must have made a mistake somewhere. So I just want to make sure this is 18, right? 1 over x plus 3 plus x squared plus 11x plus 30. X squared plus 4x plus 4, x squared minus 3x minus 18. Go back here. Negative 6 and 3 is good. Come back up here. X squared plus 11. And again, that's showing you the difficulty of these problems. Is sometimes you can just make a silly mistake. There is no negatives. Interesting. Sorry, guys. Just got to figure this out. I'm sure some of you guys are screaming at the screen like, hey, you did this. You didn't do this right. 1 over x plus 3. X squared plus 11x plus 30. X squared plus 4x plus 4. X squared minus 3x minus 18. X squared minus 3x minus 18. Man, it looks like I copied the problem down correctly. My factors look correct. Yeah. I'm multiplied by that. The x minus 3s, the x plus 3s cancel, leaving me with x plus 6. This canceled, that canceled. X squared plus 11x plus 30 equals x squared plus 4x plus 4. X plus 6 plus x squared plus 11x plus 30 equals x squared plus 4x plus 4. X and 1x plus 11x is 12x. 6 and 30 is 36. X squared, drop it down. Subtract x squared, subtract 4x, subtract 4. Well, sometimes you just don't see it. Don't worry, you can fast forward this, hopefully. I get this. Just saw it. Sorry, guys. My factor, I didn't copy my factor down over here correct. So it's not plus 6, it's minus 6. Sorry. Gotta copy stuff down correctly. It's my day off. What do you, no, I'm joking. So that, and I was thinking, man, it has to be that right there. So it's actually 24 minus 4. And that actually changes that to 20. Okay, yeah, that makes sense. Sorry, guys. 8x is equal to negative 20. And then over 8x is then equal to negative 5/4. Okay. Not 5/4, 5/2. I'm sorry, I can't do math. If you guys aren't here, I'm just incapable, I guess. So, negative 5/2. Okay. That's that. For 18, so that's 18 on the own paper. Same thing for all of those guys. You're just multiplying. Most of the time it's going to be the bigger one that you're multiplying. Just always factor it and check and make sure that's there. I'll work, now going through here from 20 to 40 is all review, okay? So you need to go back, and again, I just wanted to touch base on what we recently did. Go back and look at this. This is obviously just a formula there. You need to find the first and the last in order to use that formula. S sub n is equal to, if you can recall, and I would always say Jesus Christ, the total number there is, times Jesus Christ, a sub 1 plus a sub n. So you need to find the first term in the set by plugging in 1, find the last term in the set by plugging in 45, and then plug into this formula right here. This is the sum formula. Going over here, identify the vertex of each. You should, I'm just going to give you this right here. Negative opposite b over 2a. That's a, that's b, and that's c. Once you find that, that will give you the h. That just gives you the x coordinate of the vertex. Then you must plug that back in to y equals in order to plug it back in here in order to figure out what the y is. Same thing here. You're going to just find the vertex. You're going to find the x coordinate of the vertex by doing opposite b over 2a. 24, you're going to solve each equation by factoring. With factoring, guys, you just need to know ax squared. You've got to have it in ax squared plus bx plus c equals 0, where a is not a negative. And in this case, you would need to add the 15 to both sides. And then 5 times 15, then find something that multiplies to be 28. Here you're just factoring some. That's a pretty easy factor problem. Here we have difference of squares, sum of cubes. Just to show you this again, that's 4 cubed x cubed plus 1 cubed, which kind of shakes out to be this, the quantity of 4x cubed plus 1 cubed. And then you've got to know that formula. A squared, b squared, and that's where that SOAP acronym comes in. It's always going to be the same, the opposite, and always positive. Okay, for a sum. Same thing over here. 29, you just need to remember this, guys, that when you're doing FOIL here, I'll work this one, negative 40 minus 40i plus 56i plus 56i squared. So you just need to know what that I squared produces, so that's negative 40. 56 minus 40 would be 16i. And then this actually goes to minus 56 because recall that I squared is equal to negative 1. So that just changes the sign there. And then that would go to negative 96 plus 16i. 29, negative 96 plus 16i. Okay? So that's that. Make sure you don't get that confused. Continue right along. Solve using the quadratic formula. Now, it's only when you're factoring that this can't be negative 1, but with the quadratic formula, it's fine. You could change it, I guess if you wanted to, but quadratic formula is fine. Over here, you're identifying the end behavior. Remember this, guys, that when it's negative x cubed plus 2x squared plus 3, it's a odd degree with a negative leading coefficient. So odd degree, if it's normal odd degree, think x cubed does that, but it's negative x cubed, so your arrow should be here and here, and make sure you write out your limit. So the limit as x approaches infinity for f of x is equal to negative x cubed plus 2x plus 3 is equal to, so as x is going towards infinity, y is going towards negative infinity. And the limit as x is going towards negative infinity, this is not in the answer key, but this is what you kind of have to show here. F of x is negative x cubed plus 2x plus 3. As x is going towards negative infinity, y is going towards infinity. Here, this is the, I showed you 3 ways to do this in chapter 3. It's the product rule. Keep in mind you could set it up like this. If you remember the lattice that we talked about, you could do lattice here. You could set it up old school and work it out, or you could just distribute property the whole thing. Totally up to you what you do there. And distribute it out. Or not distribute, multiply it out. Division. Guys, remember this. You can do long division or synthetic division. So you would put negative 7, and you'd say 1, 2, negative 34, and 7. Draw your line, bring it down, and then start multiplying. Here's the key, guys. I'm going to star this. This is what I'm going to tell you. If you are missing a power, add it in with like 0 or whatever you're missing. Add it in with a 0. So if you had like x cubed plus 2x minus 7 divided by x plus 4, before you divide it, you would need to put you need to say 1, 0, because there's a 0x squared there, and then 2, and then negative 7. Just bringing that to your attention. Here you didn't have to do that, but just saying it could be on the test. Find all the zeros and sketch the graph. If you remember, you're just factoring this right here. So what we could do is factor an x out. X times quantity of x squared minus 8x plus 15. What multiplies to be negative 8 but adds to be, or multiplies to be 15 adds to be negative 8. That should be x minus 5, x minus 3. Okay, so x minus 5, x minus 3. So then your zeros would be x equals 0, 5, and negative 3 once you set all of those equal to 0. And then your graph, you would just kind of have your graph. You have 0, 5, 3, and 5. And then you would just have to kind of graph that out in what that is. Now, here's what you know is that it starts here because it's x cubed, so it would start down here. It's going to go through 0, it's going to go through 3, it's going to go through 5, doing something like that. Keep in mind, if you ever have a multiplicity here, if you have a multiplicity, if you have the factor that's the same, remember it turns and doesn't cross. Same thing with 35. Make sure you find all the zeros, and if it says sketch the graph, you got to sketch it. I'll specify that on the test. 36, identify the parent function. So you have to say the parent function of this is going to be x cubed, and then you got to say what has happened to it. Write a function like g of x. So it looks like it's just x cubed minus 2. And it's going right one up. Oh, hold on. Right one up 2. Right 2 up 1, 2. Oh, actually, that about snuck in there. So x cubed is right 1 and up 1. And then right 2 and up 8. 1, 2, 3, 4, 5, 6, 7, 8. But this is obvious here that this is not that, but it's doubled. Right 1 up 2. Right 2 up, that would actually go to 16. So as you see there, and it specifies over there it left 1 down 2. So be careful with that. We have a piecewise function here. Just remember you're breaking it in pieces. -3 and 3. This would be left, middle, and right. Then I just gave you 3 problems. I really got antsy because on the ACT I saw this and I saw kids missing these, so I said I can't stand this. I want you to do that. Just make sure you know how to graph all those. Guys, that's it. If you have any questions, bring them in on Monday. Make sure you turn this in by tomorrow at midnight. Have a good day.